Okay, so today we're back for part two, and now we proceed to number four. By the way, I checked my answers for the previous one, and they're right. So now we move on to this next one, and it's kind of the same idea, but there's a little twist here. Since we're being asked to find again parametric equations based on a given line that's been characterized, we use a parameter t, same idea, and this line passes through 4, 2, 0. But here's the twist. It's perpendicular to both I plus j and j plus k. Now, we all know I, j, k are standard basis vectors, right? So I is the vector 1, 0, 0, j is the vector 0, 1, 0, and k is the vector 0, 0, 1. So the idea here is we just want to add both vectors together. And we get their cross product. That's how we're going to be able to find our direction vector, or the vector parallel, right? Okay, so find our vector. We want to add these two up. We get 1, 1, 0, and then j plus k, and then we get their cross product. And now we get this vector. So that's our direction vector, right? And then from there, we just continue on with the steps, right? So we find our initial point. We'll just list down the steps. So we find our initial point, and then we find our parametric equations. Okay, so our initial point, we can just say it's the first point, right? Why not? So let's just do that. So 4, 2, 0, that's our initial point. And so that means our R naught is the vector which contains that same point. And then our parametric equations in this case, we have x equals 4 plus t, right? Okay, actually, before we do that, let's complete the step here. We got that direction vector. So that's our v. Now, if you want vt, this is just going to be 1 times t. So t, negative t, t. That's it. So x is 4 plus t. Y is 2 minus t. Yeah, 2 minus t. And z is just 0 plus t, which is t. Done. I'm gonna put this a bit up. Okay. And from there, we want to find again our symmetric equations. So let's do that. Now we just plug in what we know. So we have t is sum x minus 4 over 1. So that's just x minus 4. Then for y, we have 2. Uh, actually, no, it's not 2. Which this is y minus 2 over negative 1. And lastly, we have well, we have nothing for, so z minus 0 over 1. So that's just z. Z minus 0 over 1 is z over 1. It's z. So that's the idea. Now we can actually simplify this. We can divide negative 1. It's just going to be 2 minus y. We can do that. I'll leave it this way just in case. But that's the same as, yeah, it's the same. We get it. Okay, I'm going to check if we got it. So for x, we have 4 plus t. For y, we have 2 minus t. And for z, we just have t. Four plus t, 2 minus t, and t. Okay, let's hit that submit, see what happens. Okay, we got that. Now for the symmetric equations, we're doing x minus 4, negative y minus 2, that's fine, we can do that. And then z is just z. So this should be it. Hopefully. Nice, we got it. Next. Number 5, I assume. Okay, for number 5, now this is a bit different. Still similar, but different. Here now we want to find symmetric equations. Oops. What about symmetric equations? Well, we're going to find them for the line that passes through. So this line passes through point 4, negative 3, 9, right? And it's parallel. So we're actually given both stuff now. The vector, well, negative 1, 3, 2. Right? Okay. Now, first thing we want to do, well, we actually figured out our vector. It's already there. Maybe we can try finding parametric equations first. Right? We're just doing the same steps that we did earlier, but you guys can mental this, honestly. So let's say our vector v is this thing. My head's in the way. Negative 1, 3, 2. So that means my v of t is just multiplying t to all of them. And so that means my parametric equations are x equals 4 minus t, y equals negative 3. That's our initial y naught, plus 3t. Then lastly, for our z, it's just 9 plus 2t. Now from there, we can find our symmetric equations. Right? So for our symmetric equations, well, we're just going to isolate t. Actually, we can just plug in what we know. We don't even have to isolate it. So we have x minus 4 over negative 1. Easy. Let's see if we could have gotten that with isolating t. So this is x minus 4. T is just x minus 4 over negative 1, or just 4 minus x. I'm going to keep it there just in case. For y, we have y minus r naught, or y naught, so that's plus 3, xy minus negative 3 over 3. That's it. For z, it's just z minus 9 over 2. Done. Okay, now I'm going to check. So we have x minus 4 over negative 1, y plus 3 over 3, z minus 9 over 2. Did I get any of them? Y. Or I messed something up. No, maybe. Wait, let me. So, x plus 4, no, it's x minus 4. And with a negative 3, but this one's 3 times. So that's not it. Closest is the last one. Oh, I probably messed something up in computing? Or in, oh, so this is a negative 2. I wrote the example wrong. Okay, so this, I mean, this is a simple fix. It's just negative 2t. This is negative 2. We're just adding a negative. That's it. And so if this were a negative 2t, this is minus 2t. And then these are all right. This is negative 2 though. And then that should be it. Yeah, so I'm gonna do that. See if we got it. I'm a bit scared though. How many tries? Okay, 2. Yeah, let's try it. Um, let's see. If we get good. Okay, nice. Now, this is a little tricky. Here we want to find, it looks tricky, but perhaps it's not. Find the points in which required line in A in A intersects coordinate plane. So when does it intersect the X part? Oh no, when does it intersect the planes? So we want to find particular points based on this parametric equations, right? Yeah, um so yeah, I mean, let's do it. Let's say we want to make it intersect in the XY plane. So let's say intersect XY plane. Here we're basically looking at conditions. What's a point that intersects XY plane? It's the point where X and Y could be anything, but Z should be 0. That's the only condition. And so if you were to apply that, well, let's say we have these parametric equations, right? So what we're gonna do, we're gonna find a time or a t when z is 0, and then we're gonna plug that time in for x and y, right? So let's say here we're gonna say z is 0. So we're gonna say 0 equals 9 minus 2t. Then we're gonna solve for t here. All right, 2t, t is 2t over 9, 9 over 2, right? All right, 2t is 9, t is, yeah, 9 over 2. Okay, and since t is equal to 9 over 2, we can then plug in that 9 over 2 to x and y. So for x, we get 4 minus t. So 4 minus 9 half. Then we get something out of it. So we get 8, 9 half. Ooh, look at that. We get negative 1 half. Because 8 minus 9 is negative 1. For y, what do we get? We get uh, negative 3 plus 3 of 9 half. And then here we get negative 2, 6 plus 27 over 2. 21 over 2. Because 27 minus 6 is 21. Yeah, so a point is negative 1 half, 21 over 2 and 0. So that's a point that intersects xy plane. So you can use that. Try negative 1 half, 21 over 2, 0. Right? see if we get that maybe, or unless I messed up something. But I don't know. Find out. Let's see. Oh, we got it. Yeah. So same idea. Um, yeah. So same idea is what's the next one? You want to intersect YZ plane. So what's the condition? If we're on the YZ plane, it means that x is 0, right? If you were to draw that, this is x. Did I invert it? This is z, obviously. Oh no, this is x, this is y. Then this is the foreground. Yeah, this is the foreground for the first octant because it's 8. Now I know why they call it quadrants when it's 2D because there's only 4. This one's 8, so it's an octant. Yeah, so if we're on the YZ plane, if we're on here, our points are literally on here, then our x is going to be always 0. And our y and z are going to be the same thing. They're going to be some number that we know. Okay, so we're going to do the same thing. If x is 0, you want to plug it into that parametric equation, you get t out of it. So 0 is 4 minus t. Oh, look at that. T is 4. Right? And once you get that t, now we can plug in some y and some z. So y is negative 3 plus 3 times 4. It's a clean number. So that's 12 minus 3, that's 9. Z is, I'm assuming z is just, oh no, 9 minus 2. T. So instead of t, I plug in the 4. 9 minus 8, that's 1. And so our points here are going to be 0, 9, 1. That's one point that we can get. Right? Okay, so let's use that. 0, 9, 1. Hit submit, see what happens. Nice, worked. Okay, now we do intersect xz plane. So what does it mean when we intersect the xz plane? Well, we mean y is 0. And if y is 0, then t is, I don't know, I'm not that good. T is something, negative 3 plus 3t. Yeah. So I plug in the 3 here. I get t is 1. Now I get an x value. So x is 4 minus t. So 4 minus 1, which is 3. And then z here is, I keep forgetting it. 9 minus 2t. 9 minus 2 times 1. 9 minus 2, 7. And so a point in the plane could be 3, 0, 7. Right? We have 3, 0, 7. Hmm. Okay. 2 more items to go. Okay, so number 6. So, let's see. Okay, cool. Number 6. Well, here it says we want to determine whether two lines let's just put lines. Whether lines, and then we denote them as L1 and L2. We want to we want to determine if they are parallel, skew, or intersecting. So we have, okay, let's look at line one. Line one, for L1, has parametric equations. Well, 12 plus 18, y is 16. I'm just writing it out. But each of them has parametric equations, right? Z is 4 plus 12t. L2, we have x is 2 plus 8s. Then we have y 6 minus 4s. We have z is 8 plus 10s. And what do we want here? You want to check if they're parallel, they're skew, or they're intersecting. Well, how can we tell? Let's check if they're parallel. What does it mean if two lines are parallel in 2D? In 2D, they have the same slope. In 3D, we want to check if their direction vectors are parallel. That's the only way we can check, right? Pretty sure that's what I did in the first one. Yeah, it does have like a skew here or something. Yeah, see? So I check if they're parallel by looking at their direction vectors. That I'm checking if they scale to something, right? And then I can check if they intersect. And then if they're not both, then they are skew lines. That's the idea. So here in this example, it's not parallel. It's also not intersecting. Therefore, they are skew lines. Yeah. Okay, let's do that. So I'm going to check first if they're parallel. So check their direction vectors. Oh, shoot. Check their direction vectors to see if they're parallel. Yeah. So what are their direction vectors? Line one, it's gonna be this thing. Right? For line two, it's this thing. So if we look at our example here, see how they had two lines? They looked at one, so this is one, this is three, this is negative one. So 1, 3, negative 1, right? And then same idea for the L2. They just did it in S. They made the parameter S just so that's different. So that's what we're gonna do, right? Can I write that like how they did it, maybe? I'll just write in sentences. Oh my God, I used my highlighter. Okay, so for L1, we have a direction vector that is 8, negative 4, 12. For L2, we have direction vector That is 8, -4, 10. Now, these are not parallel. They're not parallel. Why? If I multiply some k here, let's say 8, I can prove it. If there's a scalar k here, this is 8 equals 8k. K is 1. Now in the next part, -4, it's -4k. K is also 1. But when we reach 12 and 10k, we get 12 over 10 per k, which is not equal to what we got. So it has to have the same multiplier. So it means they're not parallel, right? So we can take that out of the option. Now we're going to check if they intersect. So how do we do that? Well, this requires algebra. The idea being, we can check their s, right? We can equate that. So we equate these two together. We equate these together. We equate these together. And then we find a t and s that satisfies all of them. And here, if we look at our example, that's exactly what we did. So we have 1 plus t equals 2s, -2 plus 3t equals 3s, 4 minus t equals -3 plus 4s, and we got some s and t out of it. But it doesn't work at the end. So it means they don't intersect. But here, let's try it. So let's look at the x first. For the x, so we have 12 plus 8t. We can say this is equal to 2 plus 8s. That's our first relationship between the two lines. Then we have 16 minus 40 equals 6 minus 4s. And then we have our last one, 4 plus 12t equals 8 plus 10s. Now here you notice we have two unknowns, but we have 3 equations here. So actually we can just use 2 of them. We can pick any 2, plug it into the. So let's say we got our t and our s value from some 2 equations here. We plug them in the last equation and see if they satisfy, right? So let's say we're gonna go with this one. So here we can solve for t, we can solve for s, doesn't matter. Let's say I'm gonna solve for um let's say I solve for t here. I don't know. I was trying to see which one was easier. So we have 8t equals 2 plus 8s minus 12. What is that? That's 2 minus 12, -10 plus 8s. Now I can divide t here. I get -10 plus 8s over 8. And then I can actually simplify this thing. So I get 10 over 8. So I get by 2 4 or 2 5. So I get -5/4 plus 8 plus s. Right? Okay, that's 5. Now it looks like an s. That's a 5. That's an s. Okay, we can actually switch this up just to make it nicer. S minus 5 over 4. There we go. Now we can plug in this value of t to this other thing here. Right? So let's say we got 16 minus 4. Then we plug in t in terms of s. So we have s minus 5 over 4. equals 6 minus 4s. So instead of t, we plugged in something in terms of s. And here we can solve for s. So this is just going to be 16 minus 4s minus plus 5 is this thing. Now here we can solve for s directly. Yeah, minus 4s minus plus 5. Yeah, now we got 16 plus... Oh, wait a minute. We got 0. Wait, we got 0? I just realized. So this doesn't work? Huh, or did I mess up my computation somewhere? 8t minus 12, 2 plus s, 2 plus 8s. 2 minus 12 is negative 10 plus 8s. Okay, I got that. Now t is I divide everything by 8. And then I get negative 10 over 8 plus 10 plus 8s, which is just 8s minus 10 over 8. 10 over 8 could be simplified. Just wait. 5 over 4. So this is s minus 5 over 4. Huh. I don't get an s here. So that's funny. Okay, and then we get 16 minus 4s plus 5. But then I got like what? 21 equals 6, which definitely doesn't work. Okay. So they don't intersect. I don't think they intersect. Do they? I don't think so. Mm, doesn't look like they intersect. Or I messed up writing something. 6 minus 4s, 8 plus 10s. Like, okay, I didn't mess that up. Okay, I'm checking. Yeah, they're not parallel. Um, yeah, the yeah. Yeah, they don't intersect, surprisingly. I don't think no. So no intersection. Because these immediately became 0. Or this immediately became like it doesn't make sense. So if they're not parallel and they don't intersect, it means they're skew lines. Now, what do we mean by skew? We actually defined that from our last video, from a video that I did about this a couple of days ago. Yeah. Skew lines, basically, they don't intersect and they're not parallel. And if they're not both of them, then they don't lie on the same plane. They're in a different plane. And so if they're in a different plane, then they're skew lines. So these are skew lines. So L1 and L2 are skew lines. Yeah. So that means they're skew lines. They don't have a point of intersection, and they're skew lines. Yeah, looks like they're skew here. Yeah, let's see. Okay, yeah, I got it. Yeah, they're skew. Okay, last one. Same idea here. For and then I'll call it a day. So again, you want to determine whether um, two lines are parallel skew, or intersecting. So another one of these. So we have L1, which has x is 1 minus 60. Y is 4 plus 12t. And z, if I'm not messing anything up, 3 minus 3t. 1 minus 6, 4 plus 12, 3 minus, okay. And now for L2, line 2, 4 plus 4s. Let me check. Y is equal to, for y equals negative 8s. For z, 3 plus 2, 2s. Okay, 3, yeah, and then 8s, or negative 8s. And then now we want to check if they're parallel. Let's check if they're parallel. So check. Check their direction vectors. To see if they they're they are parallel, right? Which is what we did before. So I'm just gonna say it like directly. So for L1, we have negative 6, 12, negative 3. For L2, we have 4, negative 8, 2. Now, are they parallel? Can't see it at first glance, so I'm gonna check myself. But it looks like they are, kind of. So I'm gonna do this. That vector is k times this vector. And our k should be the same for all of them, right? So negative 6 equals 4k. What's this? K is negative 6 over 4. We can simplify this. This is negative 3 over 2. So that's 1k. Now we look at 12. 12 is negative 8k. Then we see here that k is 12 over negative 8. Divide that by what? 4. We get negative 3 over 2. So it is the same for both. Divided by 4, yeah. And lastly, we have negative 3 equals 2k. And again, we do the same thing, negative 3 over 2. So we have the same, so it's parallel. Because they have the same k. Yeah, they have the same k. Do they intersect? That's interesting. Because if they're parallel, then it means they don't intersect. Because that was the next question. So I don't think they do intersect. But you know what? There's no harm in not trying. But the intuition in 2D is if two lines are parallel, then they're always parallel. They will never intersect. But what's the harm in not trying? So we're going to check if they intersect. If they intersect, then I'm going to be shocked. But I highly doubt it will work. But just to be sure. So you want to see 1 minus 60, the x components. 1 minus 60 equals 4 plus 4s. Right? And then we have 4 plus 12t is equal to negative 8s. And then we have 3 minus 3t is 3 plus 2s. 3 plus 2s. Okay, and now what do we have here? Let's try one of them, right? So let's solve for t in the first one. So we have negative 60 is 4 plus 4s minus 1. So 3 minus 4s. T is 3 minus 4s over negative 6, we got negative 1/2 plus 4 over 6, 2/3 s. Yeah, because I divide both 4 over 6 by 2. So, okay. And then now from here, can I clean this up maybe? I want to clean it up. We can say, actually, no, I'm fine with that. Now we plug it in. I'm gonna plug it in the second one. Let's say 4 plus 12. Plug in the 1/2 plus 2 over 3 s. And this should be equal to negative 8s. And let's check for again s. Right? So we have 4 plus, not plus, 4 minus 6. Negative 12 over 2 is minus 6. And here I add 24. 12 times 2, 24. Plus 3, divided by 3s is this. 4 minus 6 is negative 2. 3s, 8s. Now I can switch one of them. I'll probably do like, what, 24 over 3s plus 8s equals 2. So I put all the s's in one side. I get, 24 over 3 is 8. Anyway. Okay. Yeah, now just double checking. So this is 8s plus 8s. So this is 16s over 2. And we got s being 2 over 16, 1 over 8. So that's one s that we know. Still not sure though. Can we use this s to find our t? Right? So to find our t, we actually just use this 1/2 plus 2 over 3s. But instead of s, we do 1/8, the value that we got. And now we've solved that for t. So we're gonna get 1/2 plus, we can actually cancel. This is 1, 4. And then we get 1 over 12. And then we can 1 over 12 minus 12, 6, negative 5 over 12, which is my t. So that's my t. Okay. Sorry if it's messy solving. Now I got t, I got an s. Now I'm gonna plug it in this last one, see if they intersect. So I get 3 minus 3 of this thing. Negative 512 equals, and I put a question mark here. Is it equal to 3 plus 2, 1/8? 2 of 1/8. So again, I can make this 1, I can make this 4. I can actually also, I can make this 1, I can make this 4. Look at that. So this is 3 plus 5 over 4, which is equal to 3 plus 1 over 4. That's definitely not. It doesn't work. So yeah, I mean, it doesn't work. So again, no intersection. 3 plus 5/4 is different from 3 plus 1/4. I couldn't even be bothered to solve it. But they are parallel. Don't get me wrong. So yeah, my intuition was right. Okay, so they are parallel. It's a myth. Let's see. Yay, we got it. Okay, that's it for this video, and I'll see you guys in the next one.